topic for today is elementary probability theory. So what is probability? Probability is simply how likely something is to happen. When we're unsure about the outcome of an event, we can talk about the probabilities of certain outcomes. That is how likely they are. The analysis of events governed by probability is called statistics. So how do we assign probabilities? First is by intuition. Okay, simply by intuition. Second is by relative frequency. Okay, so how do we compute for this? This is F over N. That F is our frequency and N is the total number of outcomes or the number of values. Okay, so this one follows the law of larger numbers that in the long run, as the sample size increases and increases, the relative frequencies of outcomes get closer and closer to the theoretical or actual probability value. Okay, and the third one is equally likely outcomes. That is, probability of an event is equal to the number of outcomes favorable to that event divided by the total number of outcomes. So for our example problem, human eye color is controlled by a single pair of genes, one from the father and one from the mother called genotype. Brown color B is dominant over blue eye color L. Therefore, in genotype BL, consisting of one brown gene B and one blue gene L, the brown gene dominates. A person with BL genotype has brown eyes. So if both parents have brown eyes and have genotype BL, what is the probability that their child will have blue eyes? And what is the probability that the child will have brown eyes? Okay, again, let us list down all possible outcomes. We have here the father that has BL genotype and the mother that also has BL genotype. Okay, so let us combine. We have here BB, BL, BL, and LL. Okay, so what is the probability that the child will have blue eyes? So that is equal to, we only have 1 since BL genotype has brown eyes. Okay, so that is 1 over 4, that is 0.25. Okay, so the probability of having brown eyes, that is equal to 1, 2, 3. Okay, that is 3 over 4, and that is 0.75. Okay, so another example. Professor Gutierrez is making up a final exam for a course in literature of the Southwest. He wants the last 3 questions to be of true-false type. So in order to guarantee that the answers do not follow his favorite pattern, he lists all possible true-false combinations for 3 questions on slips of paper and then picks one at random from a hat. So what is the probability that all 3 items will be false, and what is the probability that exactly 2 items will be true? Okay, again, let us list down all possible outcomes. So 3 questions answerable by true or false. So it can be all true. Okay, true, 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 false, true, false, true, false, true, true. Okay, it can also be false, 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 true, false, true, true, false, and then true, false, false. Okay, so we have 8 outcomes. Okay, so there, the probability of having 3 items false, that is equal to 1 over 8. And then the probability of exactly or having exactly 2 items true, that is equal to, we have 1, 2, and 3. Okay, so that is 3 over 8. Next, for complement of an event. So the sum of all probabilities assigned to outcomes in a sample space must be 1. There is no probability greater than 1. Okay? So we have here P plus Q is equal to 1. Okay, so P is the probability of success and Q is the probability of failure. Okay? So here we have P plus Q is equal to 1 since the sum of probabilities of outcomes must be equal to 1. So if P plus Q is equal to 1, then Q is equal to 1 minus P. So as with P, that is equal to 1 minus Q. Okay, so for event A, the event not A is called the complement of an event. To compute the probability of the complement of A, we use the probability not A is equal to 1 minus P of A. Okay, so for our example, okay, so here the probability of not having blue eyes is equal to 1 minus the probability of having blue eyes, and that is equal to 1 minus 0.25, that is equal to 0.75. Okay? This is our example for complement of an event. Okay, so I have here some important facts of or about probabilities. So first, the probability of event A is denoted by P of A. The probability of any event is a number between 0 and 1. The closer to 1 the probability is, the more likely the event is. The sum of the probabilities of outcomes in a sample space is equal to 1. Probabilities can be assigned by using 3 methods: simple intuition, relative frequencies, that is F over N, and a formula for equally likely outcomes, that is equal to the probability of an event is equal to the number of outcomes favorable to that event divided by the total number of outcomes. And the probability that an event occurs plus the probability that the same event does not occur is equal to 1. Okay. So, for compound events, we have here some probability rules. For P of A and B, it means that A and B can occur at the same time. Okay? So we have here, for independent events, if the first event does not have any effect on the probability of the second event, then that is said to be independent. We can simply multiply P of A times P of B. Then, for dependent events, if events are dependent, then we must take into account that the changes in the probability of one event caused by the occurrence of another event. So it means that the second event was affected by the occurrence of the first event. So we have here P of A and B is equal to P of A times P of B given A has occurred, or P of B times P of A given B has occurred. Okay? So, let us compute for these examples. Suppose you are going to throw 2 fair dice. What is the probability of getting 5 on each die? So, the probability of getting 5 on the first die or on the second die, the probability of getting 5 on the first die has nothing to do with the probability of getting 5 on the second die. It means that they are independent events. So the probability of getting 5 on both dice is equal to the probability of getting 5 on the first die is 1 over 6 times the probability of getting 5 on the second die, that is also 1 over 6. So that is 1 over 36. Okay. For the second example, compute the probability of drawing 2 aces from a well-shuffled deck of 52 cards if the first card is not replaced before the second card is drawn. Excuse me. here, the first card is not replaced before the second card is drawn. So that means that the second event is affected by the occurrence of the first event. So this is an example of what? Dependent event. This is independent. Okay, and pendant. And this one is dependent. Okay, so we have here the probability of getting 4 aces. We have here the probability of getting an ace on the first draw is 4 out of 52. Okay, times. Okay, so since the first card is not replaced before the second card is drawn, let us assume that the first card is an ace. So this will be 3 over 51. So this is equal to, we have there 1 over 221. The probability of A or B. Okay, so this is, take note of this. This is or. Okay, so these events are called mutually exclusive events or disjoint events, the events that cannot occur together. Okay, so here, if we use a multiplication in events that can occur together, here we use addition. Okay, so for this example, we have probability of getting a jack or a king that is equal to, what is the probability of getting a jack? We have there 4 over 52 plus, what is the probability of getting a king? So that is also 4 over 52. Okay, so let's add. We have there, we have 2 over 13. Okay, what about this next example? We have there the probability of getting a king or a diamond. So we have the probability of getting a king is 4 over 52 plus, what is the probability of getting a diamond? We have there 13 over 52. Since we have how many diamonds? So we have 15 in the well shuffled deck of cards. Okay, so but we can please consider that the card that we are going to draw can be king of diamonds. So that is overlapping of events. So we need to subtract the probability of getting a king of diamonds. So we have here 1 over 52. Okay, so that is, we have 4 over 52 plus 13 over 52 minus 1 over 52. So that is equal to 4 over 13. Okay. Okay, another example. The costless clothing store carries seconds in slacks. If you buy a pair of slacks in your regular waist size without trying them on, the probability that the waist will be too tight is 0.30 and the probability that it will be too loose is 0.10. So if you choose a pair of slacks at random in your regular waist size, what is the probability that the waist will be too tight or too loose? Okay, so we can just add 0.3, the probability that the waist will be too tight, plus the probability that the waist will be too loose, 0.10. So this is 0.4. Okay. Next is the trees and counting techniques. Okay. So for tree diagram, so it helps us display the outcomes of an experiment consisting of a series of activities. The total number of outcomes corresponds to the total number of the final branches in the tree. Okay, so for our example, Jacqueline is in the nursing program and is required to take a course in psychology and anatomy, one in anatomy and physiology next semester. She also wants to take Spanish too. If there are 4 sections of psychology, 2 sections of anatomy and physiology, and 3 of Spanish 2. How many different class schedules can Jacqueline choose from? Okay? So, we have here Jacqueline. Okay? So, we have here psychology, anatomy, and physiology. And then, of course, Spanish 2. Okay? So, we have there 4 sections of psychology. So, 1, 2, 3, 4. Okay. We have 2 sections of anatomy and physiology. 1, 2, 1, 2, 1, 2, 1, and 2. Okay. Next, we have 3 sections of Spanish 2. So, we have there 1, 2, 3. 1, 2, 3. Okay. Okay. So, let us count the total number of branches. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Okay. So, Jacqueline can choose from 24 different class schedules. Okay, another example. Suppose there are 5 balls in an urn. They are identical except in color. So, 3 of the balls are red and 2 are blue. You are instructed to draw out 1 ball, note its color, and set it aside. Then you are to draw out another ball and note its color. Remember, we draw out 1 ball, note its color, and set it aside. So, this is dependent event. Okay. So, what are the outcomes of the experiment? What is the probability of each outcome? Okay. So, here, we have here our urn. Okay. So, we have there 5 balls. We have 3 red balls and 2 blue balls. So, let us say this is for the red and this is for the blue. Okay. So, we are instructed to draw out 1 ball, note its color, and set it aside. So, what is the probability of getting a red ball on the first draw? So, since there are 3 balls, 3 out of 5, 3 red balls out of 5 balls, so that would be 3 over 5. Okay. What about blue balls? So, let us say, what is the probability of getting blue on the first draw? So, there are 2 blue balls out of 5 balls, so that would be 2 out of 5. Okay. So, we are again instructed to draw out another ball and note its color. So, let us say, what is the probability of getting red again on the second draw? So, this will be considering that or assuming that the first ball is red. Okay. So, we have here 2 out of 4. Okay. Let us say, what is the probability of getting a blue ball if the first ball drawn is red? Okay, so this will be, how many blue balls do we have? 2 out of 4. Okay, so here, what is the probability of getting another blue ball if the first ball drawn is blue? So it will be 1 out of 4. Okay, so what is the probability of getting a red ball if the first ball drawn is blue? So it would be 3 out of 4. Okay, so this is an example of a tree diagram. Okay, showing all the outcomes. Okay, next is the multiplication rule of counting. Okay, so here, if there are n possible outcomes for event E1 and m possible outcomes for event E2, then there are a total of n times m or nm possible outcomes for the series of events E1 followed by E2. Okay, so for our example, the Nighthawk is the new car model produced by Limited Motors Incorporated. It comes with a choice of 2 body styles, 3 interior package options, and 4 different colors, as well as the choice of automatic or transmission, standard transmission. Select an auto car dealership wants to carry one of each of the different types of Nighthawks. How many cars are required? Okay, so we have here a choice of 2 body styles, 3 interior package options, 4 different colors, as well as a choice of automatic or standard transmission. So we have 2 body styles times 3 interior package options times 4 different colors times the 2 types of transmissions. So we have there 2 times 3 times 4 times 2, we have 48. Okay? So we need how many cars? 48. Okay? Another example. The Old Sage Inn offers a special dinner menu each night. There are 2 appetizers to choose from, 3 main courses, and 4 desserts. So a customer can select one from each category. How many different meals can be ordered from the special dinner menu? So we have there 2 appetizers to choose from times 3 main courses times 4 desserts. So we have there 2 times 3 times 4, we have 24 choices. Okay? Then, another example. To open a combination lock, you turn the dial to the right and stop at a number. Then you turn it to the left and stop at a second number. Finally, you turn it back to the right and stop at a third number. If you use the correct sequence of the number, the lock opens. So if the dial of the lock contains 10 numbers 0 to 9, determine the number of different combinations for the lock. Okay. So, here we have 10 choices for the first, times 10 again for the second, then 10 again for the third. So we have there 10 times 10 times 10. Since repetition is allowed, okay, so that would be 1,000. Okay, next is for factorial notation. Okay, so here for a counting number of n, we have there n factorial is equal to n times n minus 1 times n minus 2. Please take note that 0 factorial is equal to 1, and so as with 1 factorial that is also equal to 1. Okay? So, for our example, let us evaluate 3 factorial. So, how many different ways can 3 objects be arranged in order? So, how many choices do you have for the first position, for the second position, and for the third position? So, it's simply 3 factorial. So, that is equal to 3 times 3 minus 1, that is equal to 6. Okay? So we have here, 2 minus 1, that is equal to 6. Okay? Okay, so that's all for today. Thank you and God bless.